Hello, I am Michelle Davis at the Center for Manufacturing Research at Tennessee Tech University in Cookeville, Tennessee. Welcome to the Fall 2019 Golden Eagle Additively Innovative Virtual Lecture Series. This is the 8th semester we have produced this popular and informative series. This series is hosted by TTU's Center for Manufacturing Research and the iMaker Space at TTU. Additive manufacturing is a focus of both entities, and as such, this short virtual lecture series has been planned to highlight the best practices, potential problems, technological advancements, innovations, and scientific contributions in additive manufacturing with expert talks from various institutions, industries, R&D centers, and laboratories. Today, we are honored to hear from Dr. Pisut Koomsap, Associate Professor in the Department of Industrial and Manufacturing Engineering at the Asian Institute for Technology in Thailand. His talk is titled, Sustaining Accessibility for Kids' Creativity with Additive Manufacturing. The speaker will provide his contact information for questions after the presentation is over. Thank you, and I turn the presentation over to Dr. Koomsap.
Thank you very much, and welcome everyone to today's talk. And today, more or less, I will not talk about the research, but more or less, I would like to share my dreams. I have a dream, a simple dream that one day, Thai kids, especially in rural areas, will have a chance to be familiar with additive manufacturing, just like the way they're familiar and enjoy mobile phone. Since the introduction of rapid prototyping in the late 80s, it has gained popularity quickly. With its potentials, we can quickly create objects from this approach or process. And people realize that not only that we can make a prototype, we can also use it to make tools. And it will not be a surprise that later on we thought about that we can also make a final product as well. So we will heard not just only rapid prototyping, we heard rapid tooling as well as rapid manufacturing. And because the potential of rapid prototyping is much more than making a prototype, that's why we think that the better name for this should be additive manufacturing. And if we think of additive manufacturing as a person, additive manufacturing today is an adult who, if they're in industries, will be at the seniors, engineers, or at a manager level. If additive manufacturing is in academics, we have Doctor Additive Manufacturing. And we can say that we can say that from the beginnings, we have Master Rapid Prototyping. Master Rapid Prototyping has grown up to be Mr. Additive Manufacturing. And today, Rapid Prototyping have 31 years old. With the process of rapid prototyping, we create an object layer by layer from the ground up. But the question is, if we look at accessibility, do we have the same manners that we will have the connection from the ground up, from the kid up to the professional level? The question is, who have had access to additive manufacturing? Well, in the old days, when we start introducing rapid prototyping, we have SLA in 88, SGC long, and FDM in 91. And we have SLS in 92 and 3D printing in 93. You will see that during that period, when we start introducing rapid prototyping, we have a big machine, very expensive, and the accessibility is limited to professors and researchers at top research university as well as research institutes. And it might also that some big company will have accessibilities to these type of technologies. And this technology has been progressed day by day. And because of its potentials, many try to develop their own. But you will see that the growth of rapid prototyping is not that much until the beginning of this decade, when the patents for all IP has expired. And from that point of view, you will start seeing that many more people have access to rapid prototyping or 3D printing. You will see that from having a unit at a research university, now we can have rapid prototyping or 3D printing in a classroom, in the teaching university, even in the schools. And you can also see that we can have these rapid prototypings not only in a big company, but we can also have this rapid prototyping or 3D printing, okay, in a small and medium enterprise. And you can also see that the trend of rapid prototyping will not be longer only for commercial purpose, not only for research purpose, but it will gradually go to the level that even kids can play with it. And you will see that one day 3D printing will be in our home, just like we have a microwave. But the question is, how about for this group of kids that lived in remote areas? Will they have the opportunities to enjoy the powerful of these 3D printing technologies? In order to have that, what can we do? The questions will be that, will we be able to bring this unit of inexpensive rapid 3D printings to our kids? The price of this unit this day will probably be around $500. Okay, but with this unit, can be sustained for the kids in the rural areas? Sustainability become an issue that we have to address. And when we talk about sustainability, there are three dimensions. We have economics, social, and environment. When we talk about these inexpensive 3D printers, for the socials, of course, it's not an issue because our kids can express their creativities. Our kids can interact with each other. And because of that, we can help build the future human resource for the countries or for the societies. In terms of environment, the material used in this process is non-toxic materials. So in that case, in terms of sustainability, in terms of environment, it will not be an issue. But in terms of reuse, we have questions on this because this day, the material that we often use will be PLA or ABS. Even though PLA is biodegradable materials, but it will take some time before all the material will be decomposed. But what more important will be in terms of economics. What we need is going to have to be inexpensive systems or inexpensive machines, such that kids in the rural area can use. In terms of the machines, I think right now the machine is not that expensive. But the question is, can we sustain the usage of this machine for kids? Because the problem that kids will have to deal with will be about materials. Having a materials like PLA or ABS, these are consumable materials that you will have to replace it one after another. Just like you have a printer. With a printer, the price of the printer is not that expensive, but you're going to have to pay much more money to buy for the ink. Similarly, with 3D printings that we have available in the market, the machine itself is not that expensive, but you have to keep buying materials one school after another school. The question for schools, in the rural areas, how much budget will they have? Will they have a budget such that they can allow kids to use the machines every day, whenever they want. This will not be possible simply because the budget for buying material for kids to play will be very limited. So, in terms of sustaining accessibility for kids, it's not the issue of the technologies, but the issue is about running the technologies. And what needs to be done is we have to explore. We have to find another type of materials that can allow our kids to keep playing day after day, which should not be PLA or ABS. We then start exploring, and believe it or not, the materials that we found out is something that you also familiar with, and that is, okay, modeling clay. Okay, the material for sustainability, or material for sustainable access is modeling clay. Okay, these clay or plasticines is a materials that we all play when we were a child. Okay, with these materials, you will see that you can bring in your creativities and start making things, building things one after another, and then create a story, and then you enjoy it. And when you get bored, you just squeeze them out and then remake to be another thing. With this type of materials, okay, kids will start with their imaginations. Then they will start creating with their hand. They will then play with this unit and share, okay, the toys with others. And then they reflect what they have just learned. And the process of kid learning will be, okay, spiraled to the next level. You will see that with these type of materials, kids can always play, okay, and can always express their ideas. And if we will bring this modeling clay into the equation of rapid prototyping or 3D printing, then what we need to do, we will have to unpack all these pieces of modeling clay. And then we will squeeze it and put it into a tube. And what we have to do next, basically, we will just extrude it. Can this idea be implementable? Okay, that is a question. So if we can do that, then there is a chance that we can use this type of materials, okay, put in our extrusion-based rapid prototyping, okay, for kids to play. And from this kind of idea, we then start exploring. We start building out CAD models of a unit. And you will see that a unit is not that fancy stuff. You will see that it's just a basic, simple unit that have a plate that you move on the XY directions. If we move on the Y directions, and then the nozzle head will move on the X directions, and then the whole unit can be lifted up and down in the C directions. And if we just extrude the materials throughout that nozzles, then we can start lay down the material just like FDM. And from this idea, then we can convert it to be 3D printers for kids, which might look like a miniatures. Okay, but along the way, before we reach to that point, we're gonna have to make a prototype to proof of concept. And what you see in the middle is a unit, okay, that we have built at the beginning, just to prove the concept. When we start building up this unit, what we did next is that we investigate process parameter to see whether or not we can really make, okay, an object, okay, from this modeling clay through the concept of rapid prototyping. You will see that on the left side is, okay, we will not heat the collectors. On the right side, which is the red colors, we heat up the collectors. Okay, you will see that when we not heat the collectors, when we deposit the modeling clay on the collectors, we cannot attach that to the base. On the opposite, when we heat it up, we start seeing that we can have a much better patterns. So from this point of view, then we're seeing that if we're gonna make it happen, one of the things that we need to do is that we have to heat up the base before we start the process. Then we moved on and looked inside that what should be the speed, okay, and what should be the feed rate, and how about the temperature that we should melt the modeling clay. We investigate all of these things just to see that which kind of patterns will be the most appropriate one. And we then conclude that at this point, when we have the temperature around 45 degrees Celsius with the feed rate of 80%, the speed of 30 millimeter per second, and the standoff distance of about 1.8 millimeter from the collectors. Okay, and if we also heat up the collectors, we should get a good looking pattern on the collectors. Once we have all this, then we come to this point when we build a unit. What you see in the middle, that is a rapid prototyping or 3D printing that we develop for kit, just to test the concept. With this unit, what we will use, you will see on the right side that first, kit can use the open source software just to download the CAD models and then slide it and then send the command to the unit and then just click print. And after that, the process will continue one after another. And kids can explore from the websites, search for the model that they like, or if they have the abilities, they can start working on designing all these things by themselves and then load onto the machine. And you will see that at the end, we will just print modeling clay. And with modeling clay, when you don't like it, you just squeeze it and put it back into the tube, and then you reprint it again and again. You will see that just one pack of modeling clay, which will cost you less than 50 cents. Kids can keep playing one after another. And with that, there is a high chance of sustaining accessibilities for kids to use additive manufacturing. And what I just want to show you here is that how the unit is working. Okay, this unit we call it Pan Fan. Pan Fan is the Thai name. Okay, the meaning of it is shaping a dream. With this unit, okay, this is the design of the unit that I have shown to you. This is a prototype that we built on the designs. This is material put in the tube, put on the unit. We create the models and then just click start. You will see that the machine will start running and start printing modeling clay out of the nozzles. That's simple. So what you will see in terms of the technologies is not that complicated, but with the material that we use allows kids to keep playing this unit. Okay, and when kids playing this unit, the cost of playing is not that high. They can keep playing day after day. Okay, they can buy different color of modeling clay, start creating their own story, and then use this unit to build the part piece by piece, and then enjoy with their creativities. This is the final product out of it, and we can be able to build or make different type of cartoon characters, which will help kids explore their creativities. Okay. And to take a close look, you see that with this simple unit, with this type of materials, kids can explore various cartoon characters, just like these Pokemons. Okay? And the cost of exploring all this very cheap. Within $1, they can make many of these cartoon characters. And after we test that in our lab, then we want to share this script. I told you at the beginning that I have a dream that Thai kids should have chance to be familiar with this unit. So we contact a company. In this particular case, we contact SCB or Siam Commercial Bank in Thailand. They help us, they provide the fundings for us to build 3 units of this fund. And then what we did after we built this unit, we just went to several schools in the rural areas. First, we went to the east part of the countries. We gave this unit to the schools, and we trained instructors there how to use the machine. After we finished this one, then we moved up north to another schools, did the same thing. Okay, we gave the machine to the schools. We trained instructors as well as students there, such that they know how to use the unit, and then they will be our ambassador to train their students. After that, we also moved to another part of the countries. And what you have seen so far, we built 3 units and give to 3 different schools in different parts of the countries. But this is just the beginning of our journeys. And because the unit is not that expensive, we also think about having this unit in our lab in order to do other type of research. And what you are seeing on the screen, we call it Fund Duo. In this case, we make 2 units of Fund, and then they will do collaborative work. And we want to use this unit to study about how we will make collaborative manufacturing. And I just want to finish my talk with all kids have creativities. What they need is opportunities. And more importantly, they all should have the same opportunity. Thank you very much.